relevant variables in acid-base titration. This is another aspect of chemistry practical that chemistry students need to take note of. In fact, in this part of acid-base titration, if as a chemistry student you are conversant with all these variables, I believe you are good to go as to the practical. Now let's start. The relevant variables in acid-base titration majorly consist of 6 variables, and the 6 variables are CAVA, CBVB, and NANB. So in this part, we are going to explain each of these variables. Ca simply means concentration of acid, and the units of Ca is mole per dm cube. So either you write it like this or like this. If you are asked to calculate the concentration of acid in acid-base titration practical, please always take note to add the units to this variable, which is Ca. Then the next one is Va, which is volume of acid, and the unit for volume of acid is cubic centimeter or cubic decimeter, depending on the question you are given. Then the next variable we have is Cb, which is concentration of base, and the unit to that variable is mole per dm cube, or you can also write it like this. Vb is volume of acid, and the unit for volume of base. Vb is volume of base, and the unit of Vb is cubic centimeter or cubic decimeter. Now, as a chemistry student, when you see this variable Na, sometimes they might write it in capital letter N, and A is still the same thing. It means amount or number of moles of acid, and Nb is amount or number of moles of base. Whenever you see A, just have it in mind that you're talking about acid. Whenever you see B, have it in mind that you're talking about base. So basically, these are the 6 variables in acid-base titration. Now, how do you know when to make use of this variable in carrying out acid-base titration? In such practical, please always take note. When you are given, in the questions that you'll be given in acid-base titration practical, whenever you see an equation, probably something like this or something like this, provided there's an equation there, just have it in mind that you are going to make use of this formula. CAVA all over CBVB is equal to NA all over NB. Equally, if in the question they didn't stipulate an equation, you are not seeing any equation there, also have it in mind that you are not going to make use of this formula CAVA all over CBVB equal to NA over NB. So I believe that is clear. Now, how do you know? Okay, before I talk about that, in acid-base titration practical, majorly you'll be given 2 reagents, acid and base. Always take note, you'll be given 2 reagents, acid and base. And if you are given an equation, these 2 reagents will be evident in the equation. Like, for example, if you look at this example 1, hydrochloric acid, HCl. As a chemistry student, you are supposed to know that that is an acid, plus sodium hydroxide. Similarly, sodium hydroxide is a base. Now, When you're able to differentiate the two reagents from the equation, you now check the number or amount of moles of each of these reagents. Now take for example for hydrochloric acid, the basicity of hydrochloric acid here is 1. That is why you are seeing Na, that is number of acid or amount of acid is equal to 1. While for base, the basicity of base here is equally 1. And if you also take note, looking at the product, we have sodium chloride and water. Like I said, in the questions, you will be given two reagents, acid and base. You will not be given salt and water. So that's why we are not looking for the number of or amount of salt or water here. So I'm basically dealing with these two, hydrochloric acid and base. So that is how you are going to bring out the number of acid and the number of base. Now let's proceed to the second equation that we are given here. Now if you take note from this second equation, can you differentiate acid and base there? If you take note, the acid we have here is sulfuric acid or tetraoxosulfate 6 acid, while the base we have here is potassium hydroxide. Note that this is a base. So this is the acid and the base that we have. This is potassium sulfate and water. Now, how do you know the amount of acid that you are given here? What you simply do is you take note. We have the basicity of acid here is 2. How do you know that it's 2? 2 times 1. Everything is standing on its own. 2 times 1 is sorry. From this equation, the number of acid we have here is 1. We have 1 acid here, and if you look at the base, potassium hydroxide, we have 2 amount of base here. Now, how do we know that? Now, let's go back to the first equation. You know, we said we have just 1 number of acid, hydrochloric acid here. So how to study an equation is, when you notice that something is written here, like for this, you are seeing 2 potassium hydroxide. So you just use that to know that the number of base here is 2. But in this case, they did not write anything here. You notice that this place is just empty. Nothing is here. It shows that it is 1. So the same applies to this sulfuric acid here. Looking at this place, it's empty. So it means we have just 1 mole of acid. So these are some of the variables in acid-base titration. Please always take note of everything we have said here. And we implore you to please subscribe to our channel for more videos. And basically, we are going to focus on practicals. Most of the videos that you'll be seeing on our channel will be basically practicals, both volumetric analysis and qualitative analysis.